we can find the length of a planar curve in a closed interval from a to b using the arc length definite integral. So if we construct a triangle that has a length delta s along the curve, well, we can denote the other dimensions as delta x and delta y. And now using Pythagoras' theorem, we obtain the following relationship. And then factoring out delta x squared, and I've taken the square root of both sides, and in the limit as delta x goes to 0, we obtain the following expression. Where y dash is the derivative of y with respect to x. And if we integrate both sides from a to b, so we have SA and SB, and on the right hand side we integrate from XA to XB. And this here gives us the length of the curve between A and B, or the total distance that a particle travels along the curve. Now you can instead divide through by delta y squared and do similar algebra, and you'll be able to obtain this integral with respect to y. And I'll leave that for you to do as an exercise. Let's verify that the arc length of a line from x equals 0 to x equals 1 is root 2 using both the integral and Pythagoras' theorem. So this is the arc length integral. And we're integrating with respect to x according to this question. Now the derivative is equal to 1. So what we get is an integral from x equals 0 to x equals 1 by the square root of 1 plus 1 squared, which is 2. And now evaluating this integral, you're going to get root 2. And using Pythagoras' theorem, you'll also see the distance between this point and this point along the line is also root 2. Let's find the arc length of the following curve from x equals 1 to x equals 4. So we're integrating over x, so we use the following arc length integral. Now the derivative y dash is equal to x to the 1/2. So therefore the arc length is equal to the integral from x equals 1 to x equals 4. And we're integrating the square root of 1 plus x to the half squared, which is 1 plus x with respect to x. And now you can easily evaluate this integral and post your answer in the comments. Let's find the arc length of the arc sine of x from y equals 0 to y equals pi on 2. And we'll only set up the integral and not evaluate it. So because we're integrating over y, we use the following arc length integral. So to obtain dx dy, we can take the sine of both sides, and therefore dx dy is equal to the cosine of y. So therefore the arc length is equal to the integral from y equals 0 to pi on 2, and we're integrating the square root of 1 plus cosine squared y with respect to y.